My presentation. So I'm going to be talking about STEM or STEAM. So science, technology, engineering, sometimes people add art, that's the A, and math. So let me just transition to that. And since I didn't have an opportunity to share a couple of resources during the Lunch and Learn, because we had so many wonderful organizations that wanted to join in, I'll probably share a little bit of that at the end of my presentation. So let's do this. Okay, so slideshow. Okay, creative problem solving and STEAM. Well, let me just go back for a moment. So something that Michelle mentioned that I think Ian also meant, like different people have mentioned kind of throughout the day, and that I kind of learned in a training that I did on STEM, was that it's really helpful, whether in a STEM lesson or just any lesson, to start with something that is engaging, right? So whether it's a story or a photograph, or just asking students what they notice, whether it's something that they're touching inside or outside, or what they feel, right? But really getting them to think about what they notice, right? Starting with something that's not a right or wrong answer is really impactful. Whether it's showing a map of different landforms and you're teaching about, plate tectonics or something, but you just show a map of landforms and like, okay, students, what do you notice? Like take a few seconds to think about it, and then maybe they notice that like, oh, like the shape of South America seems to kind of fit with Africa, and like then you can start to talk about other things like that. But there's so many different ways to go into that. But anyway, so problem solving, like you're noticing a problem, right? STEAM, STEM, same kind of idea. So I'm gonna kind of explore what STEAM is, how I've defined it, and how, like I went to a training from the University of Notre Dame. They have a great STEM program there, which you can, I think that the deadline is just passed, but teachers can sign up in the future, and you sign up in groups of 3 to 5 teachers, and they pay for everything. That's kind of where I got the idea to have the like $100 stipend and to provide everything that I can for you, that we can, as an organization and through the grant. So STEAM activities integrate concepts from 2 or more of the subjects, science, technology, engineering, art, and or math, to address or solve a real world problem. So I really I'm emphasizing this real world problem, right? Like I've heard of lots of so-called STEAM or STEM activities that they get kids doing things in a hands-on way. That's great. Being kinesthetic and having, that interaction, that hands-on engagement is phenomenal, but it's not necessarily STEM or STEAM unless they're doing something with that, right? They're going further. They're solving a real world problem. They're doing something that actually is relevant and useful in the world. STEAM activities empower students and encourage creative problem solving through the engineering design process. So I'm going to explore a little bit more about that. You might already know, I heard some of you have had some experience with STEAM or STEM, and but it's newer to some of you just based on this, initial application surveys. Okay, so I taught science, scientific method. This is slightly different than how I taught it, but basically it's kind of this sequence, right? You observe something, you notice something, then you have a question about it. Like, why is that plant starting to turn brown? Why are the leaves starting to turn brown? But this other plant that's the same kind is right next to it is not having that issue. So it starts to, pique that curiosity. So you ask that question, and then you start to research. Okay, like why do plants' leaves start to turn brown? Like, is this coloration because of water, light? Maybe you notice that one plant is slightly more in the sunlight than the other, or maybe you notice that your cat has been getting into one of the plants and is causing a problem. So you hypothesize. What are the possible solutions? Then you might design an experiment, test the hypothesis, draw some conclusions, report or share your results. So the engineering design process is kind of similar, right? So you're defining the problem, you kind of have a sense of what's going on, or you're noticing that there is something. But then you're trying to think about the solution. So you start to, it's like a solutions-oriented model, as Ian talked about. So you're identifying constraints on the solution, whether it be time, money, materials, what criteria would make for success. So whether that's, environmental impact, economic impact, social impact to the community of something you'd want to start. then brainstorm multiple solutions. That's another thing I always like to highlight, is that you're not just coming up with one idea. Sometimes the most creativity can come when you have multiple ideas. You know, maybe you combine an idea from your third and your seventh idea, right? So I always try to get people to brainstorm multiple ideas, because your first one may not be your best one. Select the most promising solution, prototype or kind of try out that model that you've made, you know, test, evaluate, iterate, or try to improve, retest. I like to retest, and then you can communicate your solution. So let's see here. I'm going to show, I do need the sound. So I'm going to show this very brief video. Not sure if you've seen it before, but it's pretty short, just kind of is an example of using the engineering design process in our everyday life. So let me just bring that up. And are people hearing that? Can someone just like unmute and say like, yes, I could hear the little doodly-dee music.
Yep, can hear it.
Awesome.
The engineering design process is a lot like making tacos. Here's how. Let's say you've had a long day. Maybe you've gone to class. Maybe you just got off work. Maybe you just finished an intense workout session. It's now 7 o'clock and you're hungry, but you've got friends coming over in half an hour. So, what do? You go through the engineering design process. First, you define a problem or need. In this case, the problem is you're hungry and you've got people coming over in half an hour, and they might be hungry too. Next, you do some research to figure out the design requirements and your limitations. So in this case, you'd assess things like ingredients you have at hand, money you've got to spend, how much time you have before people start showing up, how many people you have to feed, and if any of those people have dietary restrictions. Once you've got a pretty solid list of criteria and constraints, you can start brainstorming ideas for solutions. Maybe you look online at nearby food options. Then, maybe you go to the fridge and you start figuring out what you could make. You weigh your options and you determine making something at home will be cheaper and faster than ordering something online. And you decide everyone likes PB&J, but you don't have gluten-free bread.
Oh.
But you do have corn tortillas.
I guess I'll try PB&J on corn tortillas.
And you make a prototype. You test it out and take a bite. It's gross. But you want to make sure it's not just you, so you get others to test it out, like your roommates or family. Everyone agrees. It's gross. You ask questions and determine what's gross about it. In this case, your testers like the tortillas, but not so much the PB&J. So you go back to the kitchen and reassess. This is what engineers call iterating, making changes based on test and user feedback. You realize,
I've got ingredients for tacos? Dope!
So you start making some veggie tacos. You try one and think,
This is kinda dry.
You have other people try it to get their feedback. Most people agree.
It's kinda dry.
So you go back to your kitchen and start iterating again. You find that you've got the ingredients to make guacamole. You make the guac and you add it to the tacos. You test it out and you're like,
This is tasting pretty good.
but some of the other testers think,
It could use some spice.
so you evaluate their feedback, you look in your kitchen, and you realize you don't have anything spicy. That's when you call your friend Sam who's coming over. And you're like,
Hey Sam, can you bring over some hot sauce? I'm making tacos.
and Sam's like,
Sure.
also,
I love tacos.
it's now 7:30 and your friends start showing up. You tell your friends,
I made tacos if you're hungry. You can add hot sauce if you want.
and then you and your friends eat the tacos. They're like,
These are pretty good. I'm gonna Instagram that.
You should share the recipe online.
so you do. You've solved your hunger problem and engineered a taco party.
So that was just kind of a fun little video that shows how we can use this in our everyday lives. I'm going to take you through an example that you could use with your students. This is just a very simple thing I thought of that would relate to, you know, you're all on spring break right now. So we're going to define the problem and identify the constraints, both on the same slide. So you're leaving for a week-long vacation tomorrow, and you weren't able to find anyone to care for your hibiscus plant. You've been growing this plant for a number of years. It's just started to thrive. The plant needs consistent watering, especially if it's hot. The forecast looks like it's some pretty warm days coming up. You really don't want your plant to die. And so you need to construct a delayed or slow release watering system today using the materials found around your home in the hopes that you can keep your hibiscus plant watered, alive, and well until you return. So for the purposes of our activity today, the items around your home are going to be those items labeled STEAM for a STEAM activity. So if you can grab those out, that would be great. So what materials do you have available? So I have a couple of toilet paper tubes. All right, what do, and you're gonna have to unmute and say, I think, or maybe I can, let's see, let me, yeah, I'll stop sharing for a moment. Okay, so you can unmute and just kind of say, so I have toilet paper tubes, what do other people have?
I have a plastic baby spinach container.
All right, plastic baby spinach container. I'm seeing some milk jugs.
Half-gallon, yeah, half-gallon milk jug, yeah.
All right, half-gallon milk jug.
Yeah, smells all right.
So a couple of black plastic containers, some string maybe. Oh, the tech issues. So you got some string, some plastic, some rubber bands. Okay, so I'm gonna share my screen again, just so to like give people that visual and the tactile of like, hey, I'm holding toilet paper tubes, right? Okay, so jumping back to my presentation. Okay, so what materials do we have available? We have a number of things, right? We have string, we have cardboard tubes, we have, oh, a couple people I think had cardboard also, a couple people had to leave to go to appointment or something and come back. So, and we have rubber bands. So what about this, right? Like if you're in the classroom and you're doing a lesson, you would have certain materials provided for whatever kind of thing you're designing. I'll talk about some other examples besides a plant watering system. But so we can think about the effectiveness or lack of effectiveness of certain materials, right? The cardboard tubes may or may not be helpful for holding water, but they could maybe hold something up, right? So starting to have that creative problem solving, we're thinking in a new way. So I'm going to give you a couple of minutes to brainstorm multiple solutions. Again, multiple solutions. So maybe with your item that you have or with the items that other people have. So again, there's, you know, plastic containers, there's string, there's, you know, a couple of rubber bands, different types of things. So on your little Post-its, one of your Post-its that you have, jot down as many different ideas as you can think of. I'll give you like a minute or two. So yeah, designing a solution for watering this plant.
Are we incorporating all the other objects too, or just our
As
objects?
many as you want. Yeah, so it could be
With all
just
the
yours
things.
or anybody's. Yep.
Okay.
All right, and if this were in the classroom, like I would give a little bit more time. We are covering a gajillion things today, so give a little more time, get them to think about their ideas, but then also share out. Like maybe this would be something they actually do in a group, right? And then they might say, okay, I like this idea best because of this reason. Somebody else likes this other idea, and this may be a little different, and they might end up deciding to incorporate multiple aspects of those different ideas. And I really do want to hear what ideas you have. So maybe share them in the chat. But I also am trying to be very cognizant of time. So I'm going to continue moving forward. Well, let's see. I do have just still 3. Maybe if a couple of you would like to share your idea, because I really do want to hear them. Like, what would your design be?
Well, the thing I came up with was to take my trusty spinach tube and poke a very small pinhole in the bottom of it and use about 4 of those toilet paper tubes to like push into the soil, and then rest the spinach container on top of those, and then pour water into the spinach container. That way it would just like slowly drip, 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 and would keep the plant watered.
Awesome, thank you for sharing. Anyone else have another idea that's different or similar? John, I can't really hear you. Maybe it's, I think that your mic is maybe muted. Maybe push the little button. Is there a button on it? Okay, I think he's gonna put it in the chat. Sorry, you guys are having tech issues. Okay, any other ideas while that's being typed? Or did everyone think drip things from the spinach container?
I mean, I was drip thing from this as well, but I didn't know. I was just trying to think of a water delivery. I was like, well, maybe if you use both the 2 gallons, because you need more water. If you're gone for a week, I don't know. But I couldn't figure out how to, besides the drip, like deliver water to the plant. So, because the cardboard would just get all messy, right? And just fall apart. But yeah, I had the same drip idea, just like put a small hole in the bottom of that. But
Yeah, I did have like a drippage idea, but I was nervous it would get go too fast. So you could put like stones or pebbles or something in there. So it looks like Caroline and John added, you could use the thread as a wick. So you could have water, water in a container, and then use the thread or the string, depending on how absorbent it is, and have it travel over to, and I'll show you actually an image of this in a moment. So, but you can kind of see how, people come up with different ideas, and it's good to try things out to see what actually is effective. Okay, so let me share my screen again. Okay, so we brainstormed multiple solutions, and then you're going to select a solution to try out, or a combination of solutions. So you can see there are some examples. So kind of like on the right-hand side, the idea that a couple people had, or probably multiple people had, about, kind of draining some water out of some small holes to drip down into the container. Then there's that wick idea in the center, so that was awesome. I definitely had not thought of that until I saw this image. Or maybe having orienting a container differently, and then you'd construct a prototype. And then at this point in the engineering design process, you'd give the students a chance to test it out, to iterate, to try to improve. So it's really valuable to give them an opportunity to try out their solution or the group's solution and see what works or what doesn't work within what they're trying to accomplish. So maybe they're thinking, oh, this is going to work pretty well. And then the water either doesn't come out at all because the holes are too small, or the water is dripping too quickly and then floods the plant, right? Which is not going to work. And then it'll just get all over the floor. You'll have a mess when you get back. Plus the plant still might die if the water is not going on a delayed release. So a great opportunity for students, whether it's with this activity or another one, to really do that that's that phase of this, right? Testing, iterating, improving, and then retesting to see if something else would work better based on the knowledge they gain through the process. Okay, so a couple other examples that might be useful in your classroom. So you may or may not have heard of the landfill harmonic. So this is a philharmonic orchestra, basically, for youth, and it's in an area that has tons of trash, right? Their whole community, I mean, you can see, like, I mean, they have clothes hanging up. There's also a lot of garbage around. So they have created instruments, tuned instruments, all out of garbage. And so this could be something that you do. Maybe kindergarten, first grade, second grade, you could read something like Ada's Violin, which I don't know if you can see this and also see, let me stop for a second. So Ada's Violin is about the recycled orchestra of Paraguay. And so this shares, you know, just pictures in like kind of a kid-friendly format. And then you could have them use simple materials, some of the things that I even provided you with for today's activity, you know, simple things like cardboard tubes and maybe like a tissue box and, you know, rubber bands and things, and they can make their instruments. And then you get to a higher level, you know, the standards changed a little bit in the last couple of years, but when I was teaching 8th grade science, that was when we had to cover waves, right? Wavelengths, sound, that kind of thing, which I'm not, it's changed some, like where that's actually covered, but yeah, so I would do a wave museum actually, but the students had to make instruments that had different, that created different pitches of sound. And so there's like, you know, different constraints or different things that you'll be testing for when you're teaching a higher grade level. So based on your standards or what you're trying to accomplish, then that's what they have to accomplish and what they create. Okay, back to the slideshow. So one person's trash, another person's musical instrument. Maybe, right? That could be a STEAM lab if you connect it to a real world problem. So the problem there, they have a ton of trash and there's not as many opportunities for youths. So the way that you could connect it is, okay, you know, if you're in an area that has a lot of garbage, how can we use that garbage in a meaningful, effective, helpful way? And I think like one of their taglines is like, you know, the world gives us their garbage and we send back music. So other STEAM activities, again, they should all start with a problem or a need. So these are a few problems, some of which were mentioned in Janice's presentation earlier, right? There's increasing numbers of homeless people leading to increased amounts of waste in or near the river. So maybe the students start to devise a solution to that problem. There are lots of disposable masks that are ending up in rivers and along waterways. Maybe you have them develop or design a biodegradable mask that still is virus resistant, right? Or like it will protect people from the virus. So they have to think in different ways, like how big would the holes have to be or how small would the holes have to be so people can breathe, but also not be, you know, contracting the virus. Tree seedlings being nibbled by deer and other wildlife, preventing them from growing. So think about, okay, like can I put, maybe you cut a plastic jug and put it around the base of your tree seedling, but you know, have students devise some of these solutions to these possible problems. And the problems are endless, right? There's tons of different issues that they could solve. Okay, an important note before we go too much further. So technology can help us address existing problems and develop tools to make our lives easier. But technology can be used for good or for bad, right? So technology in and of itself isn't like always the answer because we're twofold, right? It's addressing a problem that already exists. It doesn't necessarily always inherently tell us how to go back or to fix the problem entirely. Is it like a response to something that's already problematic, as opposed to stopping a problem that hasn't started yet or something we could stop from getting worse. Humans are the people who are the ones who decide how the technologies are utilized. And if we utilize STEAM in an effective way, or in a way that I would say is the right way to do it, you can get kids to think about, you know, the implications, the ethics. So like some of those constraints, let's see, if you go back to, I just put this so you could see the engineering design process. You think about, you know, identifying the constraints on your solution, time, money, materials, add in the constraints of ecological impacts, right? Add in, a certain cost that, the city only has a certain, has tasked you with designing whatever you want them to be designing, right? Like a new walkway, but it needs to be eco-friendly and it needs to have these different constraints, right? It also needs to be eco-friendly. So we can't cut through, like maybe you're having the students design or plan out the layout of a community, but it needs to not bisect the animal habitat, right? Because some animals can't cross that busy road, and then you're reducing the genetic diversity. And I know that this is an activity in the middle school, teaching green middle years, like the bears of Banff, right? So like if as soon as you start bisecting animal habitat, then you are reducing the genetic diversity, because those bears or other species can only mate and reproduce with the other bears that are right in that area. So you could have students, design a community where they have to keep the environment, different types of species in mind. It starts to there's starting to be a lot of things they have to consider, but that's how life is, right? And that's what STEAM has to do with. So this is a way to incorporate ethics into your teaching practice, because I've looked in the K-8 standards so far, pretty much poured over them, and ethics don't come up a lot, right? So it talks about, there's a human impact, but it doesn't necessarily say like, oh, we should mindfully reduce. We can mindfully reduce, but doesn't necessarily specify, oh, we should teach the kids to reduce it. But this gives the students a chance to evaluate for themselves, right? To provide some of the information, and then they can go further with it. They can see, oh, okay, like if I were to do, if I were to make this dam or something, it's going to reduce the ability of fish to get up to where their spawning area, right? So that's not good. If I don't have the dam and there's a flood in this other area, we'll have to relocate those homes. So like they have to start thinking more holistically on a wider level. Okay, so again, as I've mentioned a couple times, I want to make sure that everything today relates back to your teaching practice. Like I don't ever want to waste teachers' time. Your time is precious, and I definitely know that. So I would like you to think about how you could incorporate STEAM. You can look through the resources in the binder, in the books, or just think about some lessons coming up. Which ones might have a real world connection? And can the engineering design process be utilized to empower students in developing solutions to a problem or addressing a need? And so let me just check my time here. I'm gonna give you maybe like 2 minutes. So I'll mute myself and give you 2 minutes. All right, does anybody have any ideas of how they might make a future lesson a STEAM activity? And I know that was a very short amount of time. You'll have a little longer this afternoon to plan a little bit better, a little bit more. And maybe it wasn't enough time. I was debating how long to have the day go because I'm like, there's so much stuff I want to include. But I will share in the binder that you received, I've started to create a resource guide that has a number of activities, at least 3 activities per grade tied to the standards that also connects to, you know, environmental protection, that kind of thing, and being engaged in nature. Oh, I'm seeing create a water filter. Yes, very cool. That's kind of like one of the ones that I have in here too. Yeah, so create a water filter from natural materials. Thank you for sharing that. There's also, yeah, like I love doing like a redesign of packaging, right? Like if you, so I'm from the Northeast and there's a lot more recycling, which the recycling system is flawed there. You know, there are still too many plastics, still too much styrofoam, et cetera, but more is being recycled, presumably. And so when I came out here for AmeriCorps, I realized, whoa, like there's so much stuff that I can't just recycle easily. And so I've been saving it. My trunk of my car is full, my cupboard in the bathroom is full, and the corner of my room is full, just from being here since like September. And so I'm starting to accumulate and see, so like a waste audit, you know, and then say, okay, like what types of packaging are we seeing? Get the students to design alternative packaging that's either biodegradable or doesn't have as much plastic, but has to still, you know, if it's something that that's microwavable, how can you still make sure it's microwavable and doesn't catch fire, right? So having certain constraints on what they're going to build. But yeah, so in this resource guide, there's a number of places where, especially like 6th grade, because I taught 6th grade, but 6th, 7th, and 8th, and then a few in the younger grades too, where you can make it a STEAM activity. And so it gives kind of instruction on how to do that. Oh, and I'm seeing another in the chat. Let's see. Creating a simple stove using tin cans to use in case of power outage. Yeah, so that's again a real world example or real world problem. So there might be a power outage.